Pele first started talking to us about some of the work he was doing in edge computing. It was super exciting. And then a few weeks ago, we sort of came to the realization that it was more than a few weeks ago. I think it was like 2 or 3 months ago when we had the Edge Compute panel. Yeah. 2 or 3 months ago we had a panel at an AI conference, and they wanted us to talk about edge compute and 5G and the sort of intersection of 5G, edge computing, and artificial intelligence. And I started off by asking everyone to raise their hand if they've heard of 5G wireless and sort of had an understanding of it. And there was two or three people that raised their hand, and I said, great.
There was 3 of us.
And then I said, keep your hand up if you know what edge computing is, and everyone's hands went down. So we had to do an edge compute panel about the future of the technology without anybody understanding what it meant, understanding what 5G wireless meant. So we took the opportunity and said, I think this is a good sort of place to do what we can to help educate the ecosystem and to bring the people who are part of the ecosystem together. So Pele and I sat down and Vache and said, like, let's create this meetup and do what we can to sort of bridge that gap. So we're super excited to host the first Edge Compute Meetup. I want to thank all of you guys for coming. Really briefly, if you haven't heard about the Future Labs, we are a network of incubators and accelerators that run in partnership between the City of New York and NYU to help New York City companies make it through the various stages of the startup life cycle. We've been around since 2009, and we focus on core technologies, not necessarily industry. So we have this space, which is the Data Future Lab, where we focus on data, so it's artificial intelligence, machine learning, edge computing. We have the Digital Future Lab for AR, VR, and the digitization of industries. We also have the Urban Future Lab, where we help companies in smart cities, smart grid. And we just launched our program that's not, the only program that we have in our portfolio that's not technology specific, and that's the Veteran Future Lab. We're working with the city, the state, and various other partners to help military veterans develop startup ventures as they transition out of the military. We just launched a new program called Catalyst, where we want to make our resources available for free to New York City companies. So if you are a New York City company, there's absolutely no sort of hidden agenda. We've been doing this for 9 years. We built a tremendous amount of resources, and we are offering it for free for 6 months for any company in any program. You can be in another accelerator, you can be in another co-working space, and we just want to make sure that we're continuing to help the New York City ecosystem, with our programming sort of events like this. I won't take up any more time because there's a lot of exciting programming that Pele and the team has planned. So again, I want to thank you guys for coming. Please make sure to tell others in your ecosystems about this event, because we will continue to do this on a regular basis. And with that, I'll turn it over to Pele.
Yeah, thanks.
Thank you.
So by now, a good percentage of you actually know who I am. I'm Pele. So we started this meetup, and as Steve was explaining, really to guide companies to figure out how to utilize what's coming up. Everyone has different definitions of what they think edge compute is. They also have different thought patterns on when things are going to be releasing, if it's 5G or when servers are going to be available. And we're trying to help facilitate and make that an easy transition, so that way your company isn't behind, but is forging ahead for everyone else. So we have our team here. We have Vache, Lisa, and Alex. And if you guys have any questions or need anything in relation to being at the event or what's happening, they have all the same information that I do and be able to help you out, guiding you to the right people via networking or even what's going on in the world of 5G and edge compute. So I'm actually the CEO of a company called Mutable, and what we're doing is we're trying to aggregate and build together all of the ISPs, telcos, and cloud providers out there. So a developer basically pushes code to us, and we deploy it on demand wherever it's needed, so you can have low latency compute for all these new cool tech toys like AR, VR, autonomous vehicles, remote gaming, so on and so forth. And so with that in mind, I'm actually going to introduce Zac and have Zac from Packet start telling us a little bit about himself and his company, and then I'll ask him some questions.
Use a mic.
I can use a mic, yeah.
Thanks.
Where is it?
Hello. Being good. Two left, good.
Can you hear me?
Yes.
Okay. My name's Zac. I'm one of the founders and CEO of a company called Packet, and we provide automated, unopinionated compute for developers. We have about 15,000 customers around the world that like to tinker on hardware but don't like to go into data centers and rack and stack it. So we try and provide an experience that allows as much opinion as possible, as much surface area of innovation for a developer to touch, all the way down to, as we like to say, the silicon. What I'm here for is to hopefully learn a few things. We've been on a journey to figure out how we make the kind of core infrastructure that allows innovative new experiences, new apps, new businesses, et cetera, to be available to more people. We happen to have a vision around how that may end up in more places and what that may look like and how that will be paid for and all that other stuff. I guess I have a question or two, which is, I know some of the people in the field here, which is really cool, but how many people actually run their own infrastructure today? 1, 2, 3. Like about half this room, right? And how many people would kind of attribute themselves essentially as a developer or somebody who writes software primarily? Okay. So that's just useful context for me. This is actually a pretty infrastructure heavy group for one, right?
That's why some of us don't run our own infrastructure.
Is because?
Because we use other people's infrastructure.
Fair enough. Yeah.
Because running your own infrastructure is,
A giant pain in the ass.
well, that's putting it politely.
Okay. Okay. So a few things that I mean, how much time do I have to?
So you have a couple more minutes, and then we'll go into just questions and stuff.
Okay, fine. So the reason why I'm most interested in this, we're a 3.5-year-old business. We currently operate infrastructure, our own, on behalf of our customers in 18 locations around the world. I would consider those the football cities of the internet. That's where the routers exist. That's where the internet terminates. And that is
Football cities mean?
just the big ones, the ones with all the people,
The
essentially.
stadiums there.
I mean, I'm calling that of the world, so we could use the football cities of America, but I'm not in all of those, and they're not all as relevant to the internet. So you might think of big internet exchange points like Ashburn, Virginia, Sunnyvale or San Jose, California, here in New York, Amsterdam, London, Frankfurt, Hong Kong. Other people in this room who probably operate infrastructure know those markets really well, because that's where we exchange traffic with other networks. And I think something that is really useful to know, I mean, right now the internet is almost exclusively driven off of those exchange points. I know we're going to talk or hear from Verizon later. You know, how do you reach an end user? An eyeball is going to be about what network you can get to. We in the content business want to put our compute as close as economically possible to that eyeball. The problem and the question is, we're just kind of on the journey right now from a developer standpoint where people are actually able to run highly distributed applications. I would say that maybe 2, 3, 4 years ago, it was the realm of a few people to operate a CDN or a large wireless infrastructure or a distributed application like Netflix or Amazon, where you actually ran your app in a bunch of places. I'm not going to say that's trivial right now, but it is becoming easier to run it in more places. However, I suspect we're going to reach a point in the coming years where all our existing models around how the number of availability zones or places we put applications is going to break. So today we're in 18 places around the world. Why do we care? I think this is a good question. Why do we care about going into more? Right? Why do we possibly care about having compute in New York City or St. Louis, Missouri? I would say that there are a few people who would come up with ideas, and there are a couple of very, very strong use cases. My personal opinion is that there will be 1 or 2 core use cases that will drive people to have compute in more locations. The first one is being that governments will make laws, and they won't just be countries, they will be cities and counties and states and other places, and those laws will just, as the internet represents more and more of your economy, you will write laws to keep more of that economy in the place where you collect tax revenue or control it. So it is my point that I think we will naturally see some regulatory effects that push us into more markets. So I believe people who write applications are going to have to figure out how to put those in lots more places, okay? The second one, which is the one that people like to talk about, it's a sexy one, is, you know, there's gonna be some amazing future where we talk at the walls and we get driven around by the cars and the refrigerators fill themselves up and, you know, we live around with glasses that, like, we don't have to stare at our phones anymore. And that's all gonna require really, really, really low latency compute to be right near those glasses and those refrigerators and all those other things. Or the drones are gonna run into each other outside, right? I would say that that's like a maybe, that there will probably be experiences that we don't expect. I like to point to, you know, that little thing that we're all slave to, right? Where 10 years ago, I thought I was the coolest guy because I had a BlackBerry, and I was never gonna let it go. Chris probably remembers I was tied to that thing. But you know, 10 years go by and look at that. I mean, who would think that we'd be watching TV on our phones? Of course, now it sounds really stupid. Of course we do that thing. So I'm sure in 10 years from now, there will be things that we think look really stupid right now that will be dead obvious at the time. We just don't know what they are. And this is kind of the catch-22 problem that I'd like to discuss a little bit tonight, which is, there's probably only one or you work for Verizon, anybody else work for a telco? Telecoms are really good at this game because they have been deploying extremely expensive infrastructure in lots of places for a long time. They understand how expensive it is. It costs billions and billions of dollars. You have to plan out years in advance. It's really hard to do, and you can afford to do it only when you know your market is going to actually be there, right?
You can also afford to do it when you buy the politicians who pass the laws, like our friends here.
Yeah, when you know the market's going to be there, right?
Yeah.
Right? So for whatever the reasons are, whether you were a government-run, government-sanctioned, you bought the spectrum.
You're not government-sanctioned, you're government-enabled. But let's go ahead.
Fair
I'm
enough.
trying to keep this
Grounded
at
in
the right
reality.
technical truthfulness level.
Okay, so for whatever reason, you know your market's going to be there. And because of that, you can afford to invest in the multiple billions of dollars that allow you to put, say, how many like central offices does Verizon have? Yeah, several thousand, right? That costs a lot of money to do. You want to go upgrade those? How many small cells are going to be for 5G? I don't know, 100,000, 200, I don't know, lots, right? These are extremely expensive propositions. What the telcos do is run an app. They run an app that allows you to have voice and data. Right? That's a pretty well-known app. They know what it is, they know how it works, they know what it costs, they make gear around it, and then they put it out there because they know what their market looks like, which is charging us $50 a month for our iPhone for a long time. I think we're in a little bit of a pickle, as it were, if we're going to go and build extremely expensive infrastructure in lots of places to run apps that we don't know what they're going to be, and we're not sure what people are willing to pay for them. That's really, really hard. And so I'm most interested in how we learn from other examples of how these types of new economies have come about. I would say that 10 years ago, we didn't all think we would have these app stores and iPhones. Maybe Steve Jobs did, but we were all dumb, and he figured it out. But let's look at other things like how the internet grew, and we can look at some good primitives of how this stuff occurs. I will say that it's probably difficult to make it occur unnaturally fast. You have to be there with the things to support it. So I'm interested in the economic drivers, I'm interested in the technical primitives, and I'm interested in learning what people are willing to pay and create with. And it's our job in the infrastructure world to make that as easy as possible. Yes?
So about 30, you know who Dave Clark is, right?
I don't.
He's one of the inventors of the internet.
Not that one.
He did a lot of the early...
Him and Al Gore?
Al Gore, if Al Gore weren't around, we wouldn't have the internet. He was crucial in passing the supercomputing funding bill. And I'm really tired of this making fun of Al Gore. Even the most conservative people in the network respect Al Gore. Read Bob Kahn's and Vince Cerf's defense of Al Gore. So about 30 years ago, Dave Clark, who pretty much built a lot of the early protocols, as did his students, professor at MIT, came down to Balfour, which at the time was the research branch of, this was shortly after the breakup, the first breakup of the Bell system in 1983, and talked about the internet. And the people from the telcos asked, well, what's the application? Obviously, this shows the complete ignorance of those people, what we call bell-shaped heads, people with no vision and no, never mind, no forethought, that they thought that the network should be about an application. And the reason we have the internet that we have today, and at least we had it a few years ago, is because it wasn't built for a particular application. It was, applications started appearing for it as it grew and drove this, drove all this innovation, and some of us were there a lot earlier than these smartphones. But I am not really buying the thing that, oh, we should figure out what the application is and build a network around it. The network has always been, the network growth has happened because there was demand for it.
It's a topic I would love to debate with you. We probably can't do it right now, but we can do it later in the show. But I would agree with you there, actually, that it is very, very difficult, if not impossible, to predict the application. I'm certainly not smart enough to do it. I'm just making the point that it is extremely difficult to ask for large-scale capital investment on something where no clear applications have shown that they're going to pay for it. And so this is kind of the pickle, I think, that people are in right now.
Yeah.
Yeah. So let's have it out, but maybe over the beer, right? So, yeah. So anyways, I'll end this with just one thing, which is, and this will come a lot, some of the people who know me know that I have a lot of opinions, but one thing I don't know is I absolutely can't tell the future. I have a lot of ideas about it. I read a lot of science fiction. So I have no idea what the apps are going to be. I have no idea what the core technology is going to look like. I don't even know what the computers are going to look like. So what Packet is doing is we're trying to I will make one guess. I do know what the end users are going to look like. They're probably going to be software developers. They're going to write the apps. They're going to interact with the things. So we're trying to build a way for those people to have primitives to access infrastructure as it becomes available or whatever. We do it against different architectures, x86 on Intel and ARM, on Intel and AMD, ARM, with Qualcomm, HiSilicon, and Cavium. If IBM will sell it to us at a decent price, we do Power 8, Power 9, and we'll do RISC-V if anybody really wants to be nerdy and get demo boards from one of the fabs. Sure, yeah.
What do you mean by primitive? It's like, I build apps for phones, hybrids. So sometimes I have to interact with phones,
Sure.
the hardware on the phone. It's sort of that. I don't think that's what you mean. I'm serious.
Well, I think it means that, hey, we have a lot of users on Packet who create their own operating system, but they're not really experts at firmware and MREs, right? So how can we give them enough to boot a system even if they want to innovate on Linux kernel? That would be a primitive for me. I want to give them the resources and the capabilities to do that through a CI system, through good out-of-band access, through access to new kernels, driver sets that work against hardware. I don't want to make them go into the Radio Shack lab and tinker with the VCR things and try and boot up the server from a demo board. I think that that's probably too primitive for most people. Maybe it's okay for the big internet companies, but they buy their own silicon businesses and do drug stops. So for the masses, I think primitives are kind of like, can I boot systems with as much opinion as I want, but without having to get my hands dirty in the cloud?
I see.
Yeah, I don't know if that explains it. And then network primitives are totally separate, so.
So let me ask one question, right, before we hand it over to Zapata. So the question would be, so we hear a lot about edge, right? But what are the different types of edge? And like, for example, device, network, so on and so forth. And what are the layers that you are focusing on versus the other ones?
Sure. I'm focused exclusively on the edge where the internet comes off of the eyeball network, right? So right now that is almost exclusively these internet exchanges or as close to the eyeball ISP that I can reach. but in the future, those may be different. One of my questions earlier was, where are the EPCs going to end up? Those will be evolved packet cores for wireless. I kind of do believe that a lot of people will get their internet off of wireless in the future. So instead of tracking where Time Warner Cable is going, I'm kind of tacking towards, where is Sprint and Verizon and T-Mobile going, right? Because what I want to know is where are they going to have their core router, usually their evolved packet core, so that we can take packets off of your mobile device or SIM card or whatever and actually speak TCP internet. Because other things are just irrelevant to my world, and I don't know enough about them. For a carrier who owns that whole edge, who owns the device, or maybe if you're an MVNO and you decide to own more of that yourself, the edge can mean something different. It can mean your car that you drive around because you're an MVNO and you run your own whole packet core, you borrow one from Verizon or Ericsson does it for you, and then you control that whole data path, so the edge can be really variable for you. For my users, it's like where the internet hits.
Gotcha. So with that in mind, you have some people constitute edge as the device itself, like on cars, on the phone. We are focused more on the network edge, so that's wherever the packets resolve after the device.
So I see that the same
network,
then.
right? So after this building, where does it go? And with that in mind, there's variations of where that could be from that point to the cloud or AWS data center or wherever it may be. And that's where you're playing with more in not directly at the but like inside of the ISP network, but you're working right outside of it, right? So that way you can.
And I think the whole concept of ISP, right, or whatever, it's Cellco, it's an MNO, it's a cable co, it's an MSO, it's wherever, however your packets get from here and they get dropped off and can reach the wider internet, that's where I'd like to be. If I have to be there to run it, if I have to be right next to it, if I have to be one building down, or where it's economical to be so. I do have a question, and Chris and I were talking about this recently about location, right? Because it's really hard before you, and we could probably spend the rest of it on like what is economical or what is close, right? I mean, the only person in the room who actually knows how close this thing is to the internet is you, right? You know what carrier radio it's on and whatnot. We have no idea. We just get to rely on something like DNS or BGP or something, right? Well, just because it's close doesn't mean it's useful to me. Well, close between what? Like close from like me to there, or between me and my buddies that I'm trying to play a game with? Or between me and the cloud service that I'm trying to interact with? Like, that's a really hard question to answer. So, and I think that will drive the economics, frankly, at the end. It's like, where should I put it is a really hard question to answer.
Definitely.
Give me an example of like, maybe something one of your clients does with packet.
Sure. I'll even make it relevant to this conversation. Okay. So recently, there's a big industry trade show around the mobile world. It's kind of a stupidly big, crazy show called Mobile World Congress. It's in Barcelona, and there's 125,000 people who all work at carriers or the vendors that service them or other people. And it's really big. And so lots of people like to show things. And we have a gaming company. Any of you ever played Angry Birds? So Rovio is they have a spin-off called Hatch, which is a customer of ours. And what's interesting about them is they're basically doing a mobile gaming platform that streams the game. So it runs the Android, only for Android right now, it basically runs the Android APK on the server, all the heavy lifting. It captures the OpenGL output, basically does all the rendering on the server, and then streams that over the wire. And then it uses the phone's GPU to effectively give you the gameplay experience, but you're not using the CPU batteries there, right? What it allows you to do is run Angry Birds, but in multiplayer, synchronized timing mode with all your friends. It also
just 2D type of games, not like 3D immersive gaming.
Yeah, all of them.
But it's all being computed. But you're saying that they're using the GPUs from the actual phones.
Yes, only to render the
For encoding.
Only for the OpenGL encoding side.
So there is a download with the app that needs to be on your phone.
No,
So
it's just you take the Hatch app and everything else after that is streamed. It's like Netflix for your phone.
right.
Essentially.
But can you access it just directly from the web with the link?
No, you have to access it through the Hatch app.
It has to
You have to go through that door. So
Yes. So then you can access hundreds of their games or games in their platform without ever having to download them. It also means that you can multiplayer them all because they can stitch together, do all the timing, do all that on the server side. Okay, that's not the interesting part. The interesting part is that they need to be within about, I mean, they're pretty clear that, and first off, they think it's a misnomer that you and I play Angry Birds together between like France and New York. That doesn't happen actually. People all play it around their neighborhoods effectively, or within their general vicinity. So they found that they need to put compute within about 20 to 30 milliseconds of the end user to make the experience really good for like a first-person shooter game, or the Angry Birds driving off the rock, or whatever they do, right? And so we help them in Europe, in Amsterdam, in Frankfurt now, and we turned on for Marseille, which is in southern France, which is kind of close to Barcelona, because they were really, really caring about how that experience was. And it was frankly too slow. It was noticeable on some first-person shooter games. Not like bad, but like, you know, they obviously cared. So we operate their infrastructure. What's unique about them is they have to run on ARM servers because they're running an Android day, right? So they can't use like regular public cloud. They actually need kind of special gear, right? And so we have to deploy Qualcomm customized ARM servers for them, which whatever market gets them 20 milliseconds closer to their user. So that would be a type of customer who runs on us. They care about cost per core and network delivery. They just happen to have to use ARM servers. So that's what we do, and I guess that relates to my previous comment about opinion. You guys may right now know, but like 99.99% of the data center business is Intel. So if you go to a public cloud, it's going to be x86. Everything's built around x86.
AMD.
Huh? Yeah, AMD x86 has like a 0.001% share. But Intel dominates that space. But some people are writing applications that need to be different. I happen to believe that all these applications that are going to cause more of our growth over the next few years will become more specialized. The current applications that are very specialized right now would be actually network workload. You don't run network workload for a carrier on a generic Intel processor. You run it on a very, very, very specialized processor or an ASIC. That's what's happening with some of these use cases as well.
There was a rumor going around a couple of years ago that Facebook was converting their data centers to run ARMs.
Yeah, there's a bunch
Well,
of...
they all have kind of, because these are just huge, massive businesses,
Yeah,
they all
exactly.
have vendor diversity strategies. So Microsoft commits about 5% of its compute revenue to between Qualcomm and Cavium. It's really just in case Intel has a phablet, and also because they buy like $10 billion a year of server infrastructure, and also because they need to beat up Intel. Right? So will they convert? I don't know. The only one who's publicly come out is Cloudflare, switching all of their server infrastructure, and they're serious about it, to ARM. But I think with those people, Google's they power.
They have a very specific business model that doesn't involve any computation, just involves moving facts around, which is makes sense.
Let's carry forward with this offline, and let's get Zapata up here.
Hey man, you're gonna have to answer this.
Well, thank you, Zac.
Hi everybody, my name is Manuel. I'm the director for Verizon for 5G. It's called use cases, testing, architecture, and all those fun things, including some degree mobile edge compute. Of course, mobile edge compute is not necessarily exclusive to 5G, but we can use the latency of 5G to make things better, or at least we want to make that. So, I'm not an official Verizon business. I don't have the liberty that Zac has in speaking about plans or ideas, but
Giant disclaimer.
yeah, exactly.
Okay.
At the bottom somewhere. Yeah, if not, it will take 6 months to get legal approval, so all that. So, it's maybe my ability what we're talking about within the industry and what everybody is thinking, right? And the reality is not only for 5G, but mobile edge compute or multi-access edge compute, as we should actually call it, is everybody's learning what it means, right? As Zac was saying, first, what do we mean by edge? And two, what is the use case, right? And for me, and within Verizon, there might be other teams that look at devices, and that's the edge for them. For me, the edge is where I stop owning the system, right? And so smartphones is not the edge for me, that's the user. The edge for me can be up to the cell site, that serves those customers, right? At least that's my definition of far from the core, right? So edge can be in the far.
And is that because the end user, it may ride on your network, but you don't actually control it, you don't own that device?
Yeah, we don't own that device. It might just be a definition that we use in my team use, because we're looking at it as what services we're going to provide, right? You might use your smartphone, but might use a tablet or a car to consume those services, whatever those services are, right? So we're focusing on effectively looking at, okay, what are those use cases? And if you've seen, one thing I can tell you, because it's public and you've seen it, Verizon is trying to be more and more a technology player than just telecommunications, right? And for some time we've been not only partnering but developing our own technologies. You have environment that is developing AR/VR. You have telematics folks, and so we are looking into what does MEC mean for all those businesses, all those use cases. But we were talking with Zac before, what does it mean in terms of the things that we're going to be able to deploy or sell? The problem is, the closer you go or you get to the customers, right, or to the edge, the more expensive it is as well, right? Cloud in a server in Iceland where you have frigid cold temperature year round, you don't need cooling, all that is much cheaper than a cell site or a compute in a cell site that is, you need to pay everybody to be in that pole, right, and just to offer some services. So it's a mix between the technology interest in how much money they're willing to pay, right? One of the things that we're doing with in general that 5G brings as a standard is network slicing, right? Be able to have a slice from the edge for me, right, from the RAN all the way to the other RAN, wherever the other user is connected, right? As part of the standard. And some customers ask me, hey, you know what, can I or will I be able to go and tell you, hey, I want one slice from the network because I need the security, whether you're talking about hospitals, for example, or news companies that need the actual bandwidth. And I say, sure, how many billions do you have to just ask me for that slice of my network, right? So all those are discussions that we're having. We have ideas, we're deploying it according to those ideas that we have. But it's going to be circular, right? Saying, okay, we have this plan, this is the offering that we're thinking, and then discussing with big customers and smaller later, and what does it mean for them, their business. One thing is clear, mainly for big and medium companies, maybe not so much for startups that are more up to date with things that are happening, is that they don't really know what 5G means or what mobile edge means, what the edge means and what they need to do, right? Everybody knows, okay, today I have two options, my phone or my computer, which is local processing, or the cloud, that is somebody else's computer far away, right? So we have been starting training them or teaching them what edge means, right? It's a closer cloud, to say something, right? It's a computer that is so close that it's as if you had the processing right there. Same thing that we were talking about rendering, just using the smartphone to render the images, but doing all the processing right in the edge, let's say. And once they understand that, they start thinking differently, right? They say, oh, if that happens, then I can offload or have these processes in the edge. That will also allow devices to communicate differently, right? Distribute things differently, put software updates or critical updates, load them to the edge, and then in those 2-3 seconds that the device comes online, immediately is cached, right? And you don't have to go through all the process of getting software from the cloud. So, in that talking with car manufacturers, again, news agencies, healthcare companies, everybody's starting to understand and to think in terms of the low latency of 5G and MET.
So with that, I don't think everyone's totally clear. What are the benefits of 5G? Like, what is it promising to bring?
Yeah, that's a good question. A lot of people think it's 4G plus 1. It is, so 5G, first of all, the standard is not finished, right? Everybody thinks it is. Part of it, half of it was finished at the end of last year.
Yep.
It's just part of it. The other half is being is gonna be completed mid this year,
Yep.
and full documentation and everything by September, I think, right? So they're still fine tuning all that, and some things might change, but just a little bit. The things that 5G bring is, whereas in 4G you have theoretical maximum speeds of 100, 150 milliseconds, right? With 5G you can get into multi-gigabit per second, right? And that's been proven not only by us, but by the Koreans and Japanese and the Germans and everybody. So normally the task that you'll have is at least 1 gigabit that you have on a simple connection, right? So that's one, but that's to me, that's great, but what's going to open more doors is latency, right? And as we were saying, right, regularly a 4G connection, including some hops inside the network, is around 150 to 100 milliseconds, give or take, maybe 100.
And
But-
how much of that is just like the technology of 4G itself, based upon brand and where it's
Yeah.
and all that stuff, and then based on where it is? Like, how much is it physical and how much is just the tech?
Hard to, it depends on the scenario. The radio is just radio length, right? So it's basically the same. It's a lot of the processing is improved, the packet, how the packets are, how the radio is actually chopped differently, the channels, and how you can dynamically chop it differently for speed or for latency, for message. So it's very hard to say. So what we are doing, right, is not only what we need to do in any company that is deploying 5G is not only improve the last mile, right, not only improve that efficiency in the packets and the beamforming with millimeter wave and all that, but also internally the network, right? And that's another part that you say costs a lot of money, is to make sure that when you have those instances that you have Mac and grade, everybody's working or playing a game in the vicinity of that Mac, yeah, the latency is great, but you have to have the same or slightly higher only latency if somebody from California joining, right, the event, right, whether it's the game plan, and that the problem that we will all know is once you jump to the internet, right, and then go out on the other side, if that link is not good, you don't have low latency, it's very bad experience. So, of course, we need to improve the network and see, okay, how do we do it, right? Do we have those links that go all to the other side of the country or the other side of the world to improve
So
that?
more expanding on your internal Verizon or ISP or telco network so you can control and not use BGP as a mechanism to transfer things, but do more internal direct communications from one side to the other.
That makes sense, right? But again, all that costs money, so it depends on the service that you want to run. If you see that the service that you're running, meaning people connect and work locally, then having those very expensive links to the other side of the world then might not be a good use case. So all those things are discussions that are happening, and we're analyzing what it means from a business side.
You never mentioned, what is the latency in general for 5G? Right, you said like 100, 150, whatever it may be for 4G, but
right
5G.
now to some
Power.
use cases here, not only from us, but from other companies, we're seeing latencies to the edge and back of around 20 milliseconds. So not only one way, but round trip 20 milliseconds. The standard can go down even further than that, but for the use cases that we're running is about that.
I'm not familiar, is there a mesh component to 5G?
Yes, so 5G as a standard has a mesh component, which means that if a cell site loses connectivity, right, or not power, but connectivity, it's able to automatically reroute traffic to other
But there's
sites.
no 5G to 5G cell phone component.
So-
I'm not gonna-
Not 5G to 5G cell phone, no. That talks about this, the tower.
No current network proposition of 5 and onwards has that infrastructure has to be followed.
Yeah,
because of
That's
the
what I
operating.
want, okay, thanks.
Yeah, so the standard calls for that, yeah.
As you know, Donald Trump blocked the takeover of Qualcomm.
Yeah,
And the
Broadcom
main concern
will-
was national security, mainly because of their involvement in development of 5G. And if you're aware of it. And that's why Intel wanted to take over Broadcom, so that they take ownership of Qualcomm and the development of 5G. Do you know anything specific about what Qualcomm is doing?
About Trump
So-
or?
Exactly.
This became political very
To have
fast,
a
yeah.
monopoly that its takeover could,
So
handle
Qualcomm,
national security by any chance.
yeah, Qualcomm actually is creating most of the chips that are going inside phones. So it's more or less who owns the chips that are going to go in every single phone. So Trump's thought pattern is, don't get me wrong, it's not Trump, but regardless, is if that the company that owns chips in every single phone is associated in some way to some other country, then therefore that either firmware or whatever it is could effectively do something with communication.
Specifically, Qualcomm owns the vast majority of the patents on 3G and 4G, and
Yeah.
Huawei owns the vast majority of the patents on 5G.
Correct.
So-
But it was also the fact that Huawei is also being blocked from being
Yeah.
sold in the US as well, right?
Again, I mean, I don't know Trump's ideas or intentions or motives, right? But in telecommunications and in the technology, there's always those takeovers, and some get blocked because of those concerns. I mean, will that mean that if Broadcom starts having 5G chipsets, that we're not going to use them? If the government, if it makes business sense and the government allows us to do it, we will use it, right? So it's, I mean, I don't
No, the reason I asked the question is just to gain some insight into what's going on in Qualcomm.
I have no
Why
idea
is
because
it
I don't
that
work
there's
with.
no other company on the face of the planet that probably is competing with them?
I think there's a lot of press releases about Qualcomm and what they're going through and IP and all that. We could
Yeah.
spend the whole day discussing
Yeah.
what's going on in Qualcomm, but I could not comment really on that.
So what was, so obviously we were all told originally, even close to 6 months ago, right? The thought pattern that 5G was going to be in 2020 is the earliest that anything is going to be shown, and now it's becoming now, right? So how is that, why is that like being expedited, or what is the thought pattern behind that?
Well, it's demand, right? It's demand on more speeds, it's demand on seeing VR, AR, in looking at the HTCs and how those guys are going to go untethered, and looking at how can I have those goggles everywhere without needing to be connected to a computer, or even locally to a computer. Is seeing the demands, again, not only in data traffic, but also in applications that have very low latency, remote diagnostics, remote, maybe not today, but remote surgery, right, are things that are coming.
Actually,
So
I have a question. Is 5G going to carry the voice as the old method of GSM compatibility, like voice as voice switching system, or do we all IP switched or soft switched?
we're doing even that for LTE, right, today.
It is
all,
also
So-
IP switched, okay.
So it could, I mean, it's not going to be everything, not only that, but a lot of features are not going to be there like 4G from day one. Because also we need to let the Samsung, Qualcomm, and Ericssons of the world implement those features, but whenever they're available, we will, if there's a reason, we'll implement them. Same as 4G, right? When it was-
8G voice was sold separately, and phones with the capability to do IP and send traffic over.
Yeah, but it was, I think the problem there was technology-wise, at Verizon, we always take care of the brand, right, or try to look at the brand. So for us, we need to have we have very high standards on what we think is good. Although the quality of voice might be good, maybe the reliability or the availability was not there for us. So until we started doing that, once we passed that threshold that we believe, yeah, we could deploy voice over 4G or LTE with the same.
Why I'm going there is that there is a use case, a possible use case where multiple speakers can be used on a phone, but due to limited horsepower on the phone, the processing may be required to be offloaded to an edge component for noise cancellation and better voice recognition and all those new applications that can be brought forward.
Honestly, I haven't looked into voice. I'm personally not too much interested in voice per se, but I'll look into that. I haven't heard that that's one of the.
I think it was the end of last year. Like,
So
you guys finished the transfer
this is what happened, right? And you can read about it. The 3GPP said, oh, we're going to be ready by 2020, 2021. Big group of people that meets every month and try to advance things. We said, look, that for what we're seeing, what our customers want, other technologies, adjacent technologies that are happening, we need this faster. So Verizon and others created a separate standard called the 5G TF, the Technology Forum Standard, right? Which for the most part is very similar to the 3GPP, and both are converging now as we speak. So the idea was to have an interim standard that the Ericssons, the Samsungs can start, Nokias can start building equipment against that standard and us testing those first features that 5G will offer, right? So that's what we did. Everybody agreed that that was a good idea, while at the same time we started putting pressure on the 3GPP, and that's why things have accelerated. So now we're starting, I think, with Sacramento next, in the second half of this year with 5G for consumers for fixed wireless access, and we'll continue to roll out starting, I think we start in July or so.
Yeah, that's a good
So
idea.
I have a question. So I know that you guys basically were deploying 5G, doing some testings like in New Jersey. Was it like consumer based? The reason I'm asking, so
Testing everything.
right, that's great. So
That's as much as we can say.
so
I mean,
the reason I'm asking is on my end, you know, I have a gaming company.
Mhm.
We are streaming console games right off of the web. No need for apps, nothing. We could power AR and VR, right? But I know with the 5G, we could actually do it without hardware. We have somebody that we could do the testing with. So just trying to figure out, because I know you were saying you were really kind of working with stuff that's like more on the back end, but not consumer facing. So
no,
Is it
we're looking at both enterprise and consumer. There's no restriction. I was just talking about enterprise because I think the most interesting, the fun use cases might be in like VR, AR, and Ready Player One and all that thing. But the most interesting challenging from the technology point of view, to me at least, are the enterprise industrial use cases.
of course,
Just me
well, I mean,
personally.
it has to
It's
work.
not that my job is just limited to that.
No, of course, I mean, you know, we're very dependent on NVIDIA GPUs, so that is.
A lot of companies.
Yeah, so it's like, right, but for us, it's like, you know, we need more than 10,000 cores. I mean, you know, there's like a limited supply, right? But at the end, I'd like to test, so I'd just like to figure out how to do that.
I don't have 10,000 GPUs.
I have 10,000 GPUs, I mean, I have the back end for that, I just would like to figure out how to test.
Yeah. So, yeah, those are scenarios, and we can talk afterwards and see if there's something.
Is fog computing on your roadmap?
So I think, yeah,
I mean, fog computing is something.
What is that?
Fog computing, if I understand, we are not using that much of fog computing term, but it's basically.
So simply said, you know, you have the cloud where it's kind of like up there in the cloud, but the fog is like the cloud, except it's dispersed to the edges,
Yeah,
so
so
the
that-
computing.
So that's what
So
we
it's-
call edge.
Yeah,
I mean,
it's
some
another-
people call it fog. And some people make the difference. Oh no, fog is same as we were saying edge. Oh no, edge is the device or not. Or is it, the fog is oh no. It's,
security we will call botnets.
so fog
Yeah.
fog is another term for the network edge.
yeah. So that's what we.
It was something that was defined, or people started using like maybe 2 years ago, But for most of us, I think we use the word network edge to kind of define the same
It's a
thing.
Cisco thing.
Yeah, somebody,
Like 5G.
I'm not surprised.
All right, great.
I agree with Zac's assessment that this is primarily cellular technology here. That's, edge technology is not going to happen on the time of our cable board. There's really only a limited number of cellular companies here in the U.S. You all are, well, be careful with how I ask this. There's a limited number of these companies. They're going to be the ultimate gatekeepers of who gets to use the technology. Do you see openness in allowing an ecosystem to develop with outside people to help build an edge compute ecosystem?
yes, it depends how you define openness, right? And where do you put that, what's yours and what's mine, right? If just put the case, if I open the door to Amazon, right? They say, hey Amazon, right? I have all these servers. What's Amazon going to do? It's like, I want it all. I'll pay you for the connectivity now. Give me all that, right? Exactly. What we would like to do, right, is go take Amazon's business. What I'm saying is, there must be a halfway where we can say, okay, this makes sense for me and for you, right? So we are looking at models and what this whole thing means. But again, what I'm seeing is that people are learning as we speak and we talk with them about how we're planning, we're thinking about mobile edge compute and what they need, and trying to find those middle grounds that make sense for both of us.
And what is the thinking around that currently? Is it building your own Amazon? Is it
I
putting
cannot,
out shipping containers?
as I mentioned, I cannot comment about Verizon's.
So what does that look like from someone that wants to build these services?
Verizon chambers.
Yeah, unfortunately, I cannot, as I was saying, I cannot talk. That's a little bit about, touches on the strategy, and I really cannot comment.
That is one built towards an edge ecosystem if no one has any idea how to interact with it.
Well, we can talk offline. We signed an NDA. I cannot talk openly, publicly.
Come on, we won't tell anybody.
I'm sure, but I cannot risk my job.
What we're trying to do at Mutable is we're actually trying to work with these ISPs because they have the physical location. That they own the compute themselves, their servers, their network, but we let developers be able to deploy containers and stuff like that on top of their
I'll
own
try to pull
system.
out some competitive information from Verizon.
I know. He tried to make sure the disclaimer was very upfront, right?
Doesn't mean I can't try.
I know. All right, great. So actually, what we're going to do now is we're going to bring up some companies that actually have some use cases that can actually use edge compute or how they currently are doing work inside of it, and give you guys a better idea of what's happening already or what should happen in the near future. To you, Chris.
Verizon, actually.
All right.
Very long.
Yeah.
Always mistake.
Hi everyone, I'm Benji Boxer. I'm the co-founder and CEO of ParsecGaming.com. We are a game streaming product like Hatch. We make it so that you can play your PC games on any device, anywhere, and you can use either your
The edge is over there, man.
You can use your own gaming PC as a host. You can use one of our cloud gaming PCs, although we don't actually own or operate any of them. We allow people to add their cloud machines to our marketplace, and we just route traffic to them. And then, or you can actually play games with friends. So if you have a cloud PC on our system, or you have your PC at home, you and your friends can all log into that same PC and play a game like Overcooked or Cuphead, some of these games that are local only, and you can play them like you're sitting on the same couch playing together. So that's really what we do. I have to run, so if you have any questions, can I take a question or two? Or
Yeah, sure.
Yeah, sorry. Anyone have questions?
Yeah, so you guys are more doing back-end for multi-gaming, like, is that what you're doing? Like, getting people to play together closer? I mean, or, I'm not really understanding the business model that much of what you guys are doing with Edge.
Yeah, so we make streaming software, really low latency streaming software, which allows people to play together or play on a cloud machine. We don't really use the Edge because there is no Edge that we use. We use AWS and we use Paperspace, and there are several other data center companies that are adding their GPU servers to our marketplace. Does that answer your question?
And NVIDIA GPU type?
NVIDIA or AMD, whatever people have.
Okay.
How do you currently determine what is the best server to use?
We actually let the user determine that. We tell them where they are.
Like physically where they are?
Yeah, I mean, because our streaming software is really good, it's about 7 milliseconds of latency added on the encode and the decode and the rendering. You really don't. We then say, okay, do you want Virginia, or do you want New York, or do you want whatever?
And that's fine.
And then typically the ping in the US is about 21 to 25 milliseconds to a cloud server. That's our median. And then in Europe it's about 33 milliseconds. So on top of that, you're a couple frames behind. It's not usually perceptible.
So what differentiates your business from Twitch?
Very different. So Twitch is broadcasting. So there's usually like a 30-second delay between when the game is being played. Ours is so low latency that you can actually play the game, like. But you couldn't do broadcasting in our model because it would require massive amounts of bandwidth.
So I've used Parsec before. I'll give a prime example. So I wanted to play PUBG, and I wanted to play it, and my machine is just crap. So what I did is I used Paperspace with Parsec, which is basically going to a remote hosting server that has cloud GPUs, dedicated cloud GPUs for a server, and then essentially press the button. It creates a Windows VM that I'm able to now control remotely from whatever device I'm on. And then I was able to play that game through that. So you run your own Steam and you install the game. Downloads are pretty quick because you're on a fast server or network already. And so that's how I utilize it. So that's a great example of the biggest thing with them is the streaming aspect of normally frame rates or doing kind of gaming. You require the frame or all the network bandwidth to be in line, like time ordered. So that way if you're missing frames, it's fine, as long as they're not out of order, so you don't have jitter. Right. So they help with making sure there's less jitter, so that way it's a smooth experience.
Yeah, I mean, basically all we do is the streaming, and then we rely on other people to do the compute. We could use edge computers and things like that.
Wherever they are.
Wherever they are.
As long as we give them access to it, they can essentially
finish. Do you charge people more based upon what the instance is, or where you're getting it, or?
They have a choice. They have a price. So everyone offers at different prices, and you can choose what you want.
It's literally like the same on-demand pricing that you're getting from AWS or like the provider that it's going. So you literally go through and it's like, oh, this is the AWS server, or this is the type that it is, exactly as it's printed on AWS, and then you basically just pay for the minutes that you use.
So what is the cost of the game?
Couple dollars, if that. Right?
Yeah, and it's hourly. So or by the minute if you're on Paperspace. But then the other thing is like if you think about it, because we have all these computers that are using Parsec, people are connecting to those computers and playing together. Friends, not random people.
Mm-hmm.
But
well, thank you. I know you gotta go.
I'm sorry.
Thank you so much.
Thank you.
So hey guys, I'm Omar and I represent Hero Power. We are a electric vehicle wireless charging company. And
Use your mic.
That's good. Yes. So and our product is to charge electrical vehicles right now when they are parked on a specific kind of a pad that we actually developed, or while they are in motion, which is dynamic charging. Our application requires that we process images as a means of detecting objects on a particular pad, because they can be of a safety threat to our product, and that requires image processing on our end. Our ground side device, which charges the car, the ground has capability which is limited in compute horsepower. So what we do is that we would be sending those images all the way up to our cloud. And in this cloud, we expect the cloud latency to be as low as possible, so as close to us as possible from a network perspective. And then the cloud can decide if the objects that it's seeing underneath the vehicle while it's delivering power to it are the objects that can be threatening to the transfer of power, or can be threatening to the safety of that particular vehicle, and then mitigate that situation as fast as possible. Another thing that we use and we are going toward using is to detect and recognize the cars that will be parked on our particular pad. And we want that in case we have a citywide application where we want to see if somebody is illegally parked on a charging location and that they have not reserved for that purpose, which is a common place in case you guys are from New York City, most of you guys would be. And we want to make sure that we can inform the city. So that requires us to do image recognition on number plates and the type of vehicle that we detect, so that we can appropriately either send them a ticket, or the city would vary, and as well as recognize if they are a particular kind of cars or not. All of these things require compute horsepower that is not built into our delivered product right now. So how we architected this thing on this future hope that edge computing from Pele would be available to us and is available to us, so that we can offload all of that kind of traffic to it and make our service appear as convenient as possible and help the job. So that is what we are doing right now. Questions? Dinner very sleepy. How many people are sleeping now?
You guys all food coma?
This charges the car while you're driving the car,
That is correct.
and gives you a ticket at the same time?
It would if it's a driverless vehicle. No, I'm just kidding. No. In a driverless, in a dynamic application, it could be a different scenario altogether. If they are not a subscriber of our service for charging, they will not get a charge fee. That's a different scenario. Here is the scenario that we actually have a mechanism where we pre-book spots for people to charge their car at.
Like parking spots?
Parking spots. So those parking spots could be prime, and there could be a contention if that particular person reaches that location. So we want to make sure that we can reprimand the other person and somehow.
It's like people who like park at Tesla's superchargers when they're not charging or they're not an electrical vehicle, and so they're taking spots of other cars that should be there charging.
Right.
So basically, it's free, making sure that people are utilizing the utility as best as possible, so that way people can actually, if you have a car that needs to be charged, you have a car that needs to be charged, right? Like, you can't be driving around all over the place. Like, you just go there.
Riding on my city bike all around Northern Manhattan.
Yeah.
Yeah.
So this makes it efficient and penalizes people for misusing it.
Yes, we want to make sure that whenever somebody is trying to book a place for charging, they have that, and since they paid for it through our service,
They have available.
They have it available. We want the adoption of electric vehicle from a charging perspective to be as frictionless as possible, and that's one of the problems.
So their main product, though, is a pad that a car drives over and then charges their vehicle. This is just things that they have to do on top of that in order to make it feasible to go in public spaces. So that way, if they're in a public space, like on the street, they can then make sure that a taxi or whatever type of car or a truck who's blocking those things, make it hard for people who are trying to actually use it, are basically decentivized to do it in the future.
There is one other little thing, technical thing that we also do, and it's in the background, is alignment of vehicles on top of our charging pads in our static application. That requires, and our experience that is given to the user is through our web app right now, our Apple or Android driven application. And we want to make sure right now, when we are on a local network, within our own LAN, of course, we have the minimum possible latency. Our charger and our phone are all on the same LAN. But in our real application, we use a backhaul provided by either Verizon or T-Mobile or AT&T, whoever our cellular provider is going to be at the end of the day. And in that scenario, if you are near to our charger and our cloud is computing the coordinates of where you should be in perspective to our charger, that experience requires as low latency as possible. So it's fluid. You don't want the car driver to drive like 6 inches forward or 10 inches left or right, and by the time he is beyond that limit, he sees that he's now passing through, and that doesn't work. Latency is the killer of our experience. Edge computing, when it becomes available through services like Verizon yourself, would make it happen in near real time for people like us. If there's an edge present, our charger is connected to the same cell site, or the person who is, let's say, of the same cell site of, in this case, Verizon client, will also get the same service for the same cell site. Now the data is near your RAN. Both of them are in the same RAN at this point. We can hope at least. Maybe, yeah. So maybe one or two similar RANs. And when they are on, they hit the server, the same server, and the probability of hitting the same server is at 60 to 70% at that point, which is awesome for us. That's why edge computing is something that is like a dream come true as far as our company operation is concerned. So, sorry.
Please observe, your site is so wireless so that the charging is contactless.
Correct.
Yes, I think we're stuck in the charging part. Sorry. It is totally contactless. We are able to throw electric charge, so to speak, at distances up to 25 centimeters.
Okay,
so if you have an SUV,
what cars support this right now?
there is no commercial vehicle online available that you can buy today. But there are lab instruments or pre-market test products out there, such as we have one too, that actually people can buy and retrofit their existing electric vehicle. We have developed products for two specific kinds of vehicles right now. We have products for Tesla, their Model S, as well as the Nissan Leaf, which their EV offering.
But potentially like an autonomous delivery device could use yours to charge and...
Anytime, yes. A predominant amount of our business model is to support charging of autonomous electric vehicles. So, and that again is a latency-driven problem. You don't want the computer to go nuts on the parking spot. I don't want it.
I think that's going to be really funny to watch.
Forward, back, forward, back, forward.
Actually, in that case, if that happens, we blame our end network provider. In this case, it could be Verizon for messing it up for us.
All my this thing's supposed to tell you exactly the sweet spot. That's why it's supposed to like exactly the optimal charging spot for your system.
The optimal charging spot should be within plus minus 10 centimeters of the center.
And this thing has to tell the car
that is correct.
where that is. So
we cannot rely on GPS again, and plus it doesn't work indoors. A lot of parking spots will be indoors in parking plazas. It doesn't work. So we have developed, to make this technology work, we have our own little GPS systems, a bunch of sensors and satellites and the whole gamut of weird things. But we make it work.
This just seems like it would be a panel on like robotic guidance systems.
Yeah, but think about that. Like, robotic guidance can really utilize edge computing to its maximum. So we are Boston Dynamics of charging cars.
I want to see it backwards though.
Anyway, yeah, any questions?
Fantastic.
All right, good. Hein, take it up.
Oh, I have one question. What would you pay for that?
For which one?
Like if it's like makes or breaks your business model, it's so awesome that you could run low latency application runtime like a Heroku at the Mac or something, right? What would you pay? Is that worth $1 to you per month per charging station?
Didn't compute it that way yet. We have a technological goal that we're trying to achieve with it. Financial goals are not considered.
Okay.
But we are hoping, as with any service, when the service, and as somebody did mention, I think you did, you can never predict the app. And you can never design a network for a future app. They have to go hand in hand, somehow it has to be symbiotic somewhere. So the prices can be determined at the time when they become available.
Thank you.
Hi, I run owl.io. We are a computer vision behavioral analytics company. So what we try to do is help you understand your space and the people in your space. We're mostly deployed in buildings, and so what we do is computer vision on your surveillance systems. We'll tell you when people are doing weird things in your space that are, causing other people not to want to live in that building. We also help track people in long-term care facilities, such as assisted living facilities, so we know where residents are without having to tag them with RFID. We use facial recognition. It's a lot more dignified a solution than some of the other things out there. So cloud compute or edge compute for us, wow. We do a lot of processing and a lot of video. All the big, computer vision companies will have these cloud models or pro query operation stuff, and that stuff's really, really expensive, and it does not scale for what we're trying to do. We started off by assuming we can run stuff on AWS, and then we realized, well, gee, that's probably not the best idea. So all our compute right now happens, or not all, but the majority of our large size compute actually happens on a gateway that actually has some GPUs on it. Fairly inexpensive. We found some nice ways to do that. It would be nice to know that there's an intermediary or some other solution in between. Comes up a lot for us is mobile sites, construction sites, school buses. We got a call today from a school board. They wanted to outfit their school buses to track where children are. It's really nice, but I can't imagine putting a gateway into a school bus with enough battery backup to keep running that thing. So IoT devices obviously are adding more and more vision to their products, and that's really nice. But the more they add, the more customers want, the larger the analytics problem is. So we don't see ourselves solving the problem at the sort of total edge. We kind of see this as a compute problem, and a compute problem that shifts. We can do some stuff in the cloud right now. We prefer to do things at the edge. It's cheaper. Is there an intermediary? Is the CO the place for us? We imagine that there's probably a point where that makes a whole lot of sense financially. Yeah, any questions? Sure.
Have you had how many or how long has your gateway been in the field, and have you had to do you worry about upgrade cycles? Or
We do worry.
Worth it refreshing them, or?
We do worry about upgrade cycles. Lee in the back is smiling because he has to deal with some of those. I'd say as a team we have a pretty strong sort of SRE backend set of experiences. So we've done a lot of this, but frankly, we hate. We don't really want to be doing this. Obviously it's hard to manage a fleet of devices. We don't want to be doing it. It's easier to manage a fleet of AWS devices, right? When the machine dies, it's just a click of a button on a web browser to get it back, versus having somebody go down to a site. So that hasn't changed.
I guess I meant from an upgrade cycle, like an actual physical.
Oh, natural physical upgrade. Well, so we've only had, and the question was how long. So I'm sorry. It's been about 1.5 years since we put our first device out there. So we really haven't had to deal with that in a big way. We are using later generation GPUs right now, so that kind of does. There are places we wish we could go back and just easily change that. Any other questions? Awesome.
Thanks. I'm going to go up the very Black Mirror Space Odyssey logo you've got going.
I'm sorry?
Yeah, okay. Got a very Black Mirror looking logo.
Well, thank you. I hope it doesn't spook you out or anything.
I just have one last question. Is you're putting gateways in the field? This is probably a dumb question. Like, how do you think about security in this kind of, let's say it's an untrusted environment, you're running your code, you've got these things, maybe you put them in lots more places. Where are you thinking of the security chain?
And you're thinking about the physical security as well as?
Well, I'm just saying, like, probably you don't trust the physical security of the box.
So we actually usually point cameras, in cases where we can, we'll point the camera at the actual physical box. Not everywhere we can do that. It has to be a really big site for us to want to do that. So we've done it in a couple of places. Generally speaking, we're relying on sort of, all sort of network tools that we possibly can. But there's a physical risk that we're not able to solve. Certainly not easily.
Well, great. Cool.
Is this working?
Feels good when you hold it.
Feels good, yeah. Feels serious, okay. I'm Chris. I'm the CEO at NS1. So a little bit of a different kind of a business. We're a core internet infrastructure business. We do DNS and traffic management for our customers, meaning we keep the domains online of all of our customers, deliver DNS responses to the queries when you type something.com into your browser. And to do this, so I have a couple of edge stories. We ourselves operate a large global edge network, well, actually a bunch of global edge networks. In our main network, something like 30-ish data centers around the world, and then in our other networks in aggregate, probably up to about 200 facilities that we're operating today. Either to offer our services in a cloud model or in a single tenant model for our customers. So that's one story, and I'll come back to that. The other story is what we do for our customers, which is a little bit more than just responding with an IP address when you type in something.com to your browser. Our job on behalf of our customers is decide which of their own global distributed infrastructure are we going to direct workload to at any given time. So if you're a user on Verizon in New York and you want to play some sort of a game, maybe with some streaming gaming service or something like that, and you're not RSEC, where your users get to choose the facility that they're going to interact with, you may want to make some decision on behalf of that user and direct them to what you know is the nearest facility or the lowest latency facility or something like that. Or if you are LinkedIn and you have 5 different content delivery networks, you might want to make some sort of a smart decision about, okay, this user wants LinkedIn.com, which content delivery network am I going to direct their traffic to look up professionals most quickly. And that's our basic job on behalf of our customers, what we call traffic management. It turns out that the edge trend is fundamental to our business. So I had just as an anecdote, a customer advisory board meeting with some of our West Coast customers in the last week or so. And I can't say all the names, but some of them that I can say, so LinkedIn was there, and Dropbox was there, and Pinterest was there, and NVIDIA and their Edge Compute Cloud was there, and a few other folks. And every single one of these organizations has an edge initiative, right? They all recognize the impact of latency, especially to their user experiences or their ability to deliver their applications effectively. There's all different motivations, right? If you're Dropbox and you're shipping big, huge objects or uploading big, huge objects into your storage engine, you really want to control the connectivity. You want to, for economic reasons, for one thing, but also for user experience reasons, be able to have users uploading to sites that are nearby, often peered directly with the Dropbox network, things like that. If you're LinkedIn, you know that the 99.99th percentile, time to first byte to download a user pick on your site, if that's poor, that 0.01% of users still is tens of millions of interactions that are happening. So you really gotta drive connectivity at the edge to reduce that latency, do caching. You might ask why LinkedIn doesn't use a CDN. It's because they can't give their TLS private material to any CDN, so they have to do it themselves. So our customers really care about this, and I would say about half of our customers are building edge networks today, or trying to leverage stuff like Packet or other businesses that have solved this problem for them in some flexible way. Back on our edge story for just a minute, we also obviously care about performance and connectivity of the DNS lookup. So when you type in linkedin.com to your browser, we want you to get back the IP address really, really quickly. This requires us to be relatively local, right? That's why we run a big, huge global distributed network. But there's a lot of other stuff that happens to us as well. So probably we're under attack right now. And we really like to keep attacks local. We like to be very highly distributed so that some big, huge DDoS attack aimed at LinkedIn or Airbnb or somebody, right, is absorbed near to where it's happening, and it doesn't impact the whole rest of the world. We also depend on services like packets, right, to be able to spin up very dynamically infrastructure close to where an attack is happening. And we see attacks into the hundreds or more of gigs a second in throughput, so we need to be able to spin up not just compute capacity to scrub packets and so on, but also connectivity, sort of on demand. So the more widely distributed and addressable it is for us to take down, call it like cookie cutter compute and network capacity closer to the edge, the more effective we can be in mitigating these kinds of attacks against our own network or protecting our customers. So a lot going on at our edge and our customers' edge. Go for it.
I have lots of questions for Greg.
You should know all the answers.
No, like, you got a lot of customers, right?
Some.
Some of them care deeply about latency, right? They've got different reasons, right? What percentage of your customers are making kind of like very clear business decisions based upon latency? And what do you think is like the threshold generally? And this is totally an unfair question, but like, is it 10 milliseconds where people care, 50 milliseconds, 100 milliseconds? Like, where is that, if you can give me broad strokes?
Yeah, broad strokes, because the real answer, of course, is it totally depends on the business, right? But imagine you're like a large social network or other like major web property, right? And probably your content consists of a lot of different stuff. Like a page load is a lot of different stuff. You spend, first of all, a lot of time, money, and energy understanding the impact that latency has on your users. And often many of our bigger customers, they have entire teams of 15 or 20 people whose job is traffic engineering, specifically to reduce latency or improve reliability or throughput or something like that, right? And so the other half of this, and then I'll actually answer your question, is it's about the audience, right? Where is the audience? How distributed are they? And this is the fundamental reason we started our business. We recognize that applications and their audiences are increasingly global. Zac knows this. I used to live in Singapore. When I first got to Singapore, exactly Facebook and Google had local presence and provided good experience. Now, everyone who lives in Singapore expects every application they're going to spend time with to have a relatively local presence and provide good quality of experience or service in their interactivity with some app on your phone or web app or whatever. Now to your actual question, right? How much do these companies care? The ones where they can tie the number to their bottom line care very desperately. So we're here in New York. Ad tech is a big thing. The ad tech guys, they can draw the function that maps response time or how quickly they serve up an ad to conversion rate or how often they win a bid or something like that. That makes it really easy. They're willing to spend a lot, right, to distribute their edge, especially closer to exchanges, but then also if they're serving up ads to eyeballs. The rest of the guys, it's a little hard to say. I would say, by the way, like we're talking the order of tens of milliseconds, not the order of hundreds of milliseconds. We have to SLA our response time globally in general, and that SLA is below 100 milliseconds. That's just for DNS lookup, of course, but these guys are in general trying to compress the entire page view down under 100 milliseconds.
Budgeted for 100 milliseconds.
It's a nice budget, yeah. And then the ad tech guys, sometimes that budget is much less.
So how does your business model work? How do you charge your clients? Do they pay you like?
They pay for the DNS traffic that they do, and then the intelligent capabilities we're bringing to bear. So when you type linkedin.com to your browser, a series of things happens, but a good chunk of the time, a DNS query arrives at our systems, and we account for that, and we meter, right?
Bean counters. Okay. Printouts of DNS.
Gotta get paid. Cool.
So how would just one other question in scenarios here? And, sorry, I forgot your
Omar.
Where, 10 milliseconds might matter to you, right? In terms of your app that you are thinking about, right? Like, are you gonna count on, like, as a software shop, right, the app or something? You know where you're gonna put your charging at. Like, you know where it sits, you probably know which RAN it's gonna hit off of, or at least maybe you rely on the carrier telling you that. In a perfect world, would you just say, hey, Verizon, I've got my SIMs from you, I'm putting them out there, I've got them from you and T-Mo, so we're all good, so you just handle my computing for me because you know where my thing is going to be attached to? Or will you be expecting to have some sort of other view on making that decision, like what this guy's providing, and say, hey, what's the right place for me to compute this that gives my the best experience or within this latency or whatever you're paying for?
I'll go the other way, because it gives me more flexibility.
You go the latter.
Yeah.
And I'm assuming you're thinking globally, right? Not just US?
Yes, globally.
So otherwise you'd have to kind of also count on,
Yeah,
50 carriers being able to do this for you.
So I need like a service that can make it transparent for companies like myself and then handle the bulk of the business themselves. I'm not in the business negotiation tariffs with operators like yourself. Not that big or that's financially.
Singtel or whatever, because you got a card.
Yeah, not our business. We don't want to be there.
That's a lot of stuff that we're trying to help take care of for them.
So would you want like Twilio to give you a digital SIM and you just handle that all for them? And like you wouldn't even have to talk to carriers?
In some
And
cases,
then
it
the,
works for us too. Yeah. In
and
Europe,
then
one of our operations uses a more globally recognized SIM versus a specific carrier SIM.
And sorry, one more question, which is, would you be willing to do something like an agreement with Verizon and say, hey, you're going to be my connectivity partner for my largest market, but I'm just going to rely on your roaming agreements everywhere? Or do you think that you would probably count on having localized partnerships, whether it was through a third party or directly?
In this case, it's like a service provider for the backhaul, like the RAN service, or the
No, for actually your radio connectivity, right?
Yeah,
So
that's
your
one.
SIM. Who's going to issue the SIM? Are you going to
Right now, we are every service provider has their tariff models in different markets. So we want to capitalize on all the possible tariff models that we get the cheapest possible for our particular service. Plus, it also depends on what our predictive clients could be in that particular tariff model. So T-Mobile could be a good IoT provider in some locations, but Verizon could be another IoT provider in some other locations.
Awesome. Any other questions to the panel? Well, thanks for your time.
Thanks, Kylie.
Yeah, I hope this guys gives you a better idea of use cases, the network edge or FOG or whatever you want to call it, and give you a better sense of who are the players that are involved in order to make this happen. We're gonna once again do another one every single month. And try and bring companies together so you can get a better understanding of use cases as well as the companies that are involved in trying to make this happen. Feel free to spend the rest of the time networking and go on your merry way.
Thank you.